Bismillah ar-Rahman ar-Rahim. Inshallah, today I'm going to explain about how to calculate the stabilizer resistor and metro cell resistor in REF protection relay. In previous session, I explained how the REF will work, and we're giving some study cases during internal and external fault, and we see what's the purpose of using the stabilizer resistor and MOV resistor. In this session, I will show you how to calculate the stable value of stabilizer resistor and metro cell resistor. Before I'm going to the calculation, we need to consider some important parameter. First, we need to know the CT ratio. The CT ratio assume is given 1200 amp by 1. Then I setting or the I pickup for REF relay is 0.1. Then we need to know the knee point of the current transformer is given 350 volt. Then also we need to know the fault current. The fault current is given 8750 amp example, and RCT it's equal to 2.5. Okay. During starting the calculation, first things we need to do we need to convert this fault current from the primary to the secondary. So how to do this? Just this primary fault current 8750 amp, I will divide it by CT primary current. How much? 1200. Okay. So how much will be equal? So will equal around 7.3 amp. Okay. So the fault current in the secondary side, it is 7.3 amp. Okay. Now we will calculate what voltage through the fault. So the voltage through the fault, Vs, will be equal I fault secondary. This one I will multiply by the resistance that connected the CT secondary. So this will be contained what? RCT plus 2R lead, because in the current transformer we have two wire, right? This S1 and this S2. So that's why we use 2. And this resistance lead we can found it from the manufacturing, okay? Plus the relay resistance, and the relay resistance we can find it from where? From the relay manual. Okay. Now fault current, how much we have in the secondary? 7.3. Just I will multiply. RCT is given 2.5 plus 2 R lead. This will given from the CT manufacturing. Assume is given 0.5. Okay. Plus relay resistance from the relay manual, also assume is given 0.5. Okay. Then we can find Vs. So the Vs will be equal, okay, so Vs will be equal 29.24. okay. Now we found Vs. Now we can find the stabilizer resistor Rs. Okay. Now we can find the stable value of the stabilizer voltage. So how to find it? Vs, I will divide it by Is or I pickup for REF. So Vs we find it 29.2. ICT is given 0.1. So will be equal how much? This will be equal 229 ohm or around 300 ohm. Okay, around 300 ohm. So the stabilizer resistor we found it around 300 ohm. So this is the way to find or to calculate the stabilizer resistor. Now we will calculate the metro cell resistor. To calculate the metro cell resistor, first we need to find the voltage drop through the fault, Vf. So now we will calculate. So now we calculate. Okay, MOV. We calculate the MOV. Okay, you need to find Vf, which is the voltage drop through the fault, will be equal I fault in the secondary. I will multiply by RCT plus 2R lead, okay, plus relay resistance, same, plus stabilizer resistor. What we find? How much we found? 300, okay. I fault in the secondary, how much we found it? 7.3. I will multiply by RCT is 2.5 plus 2. R lead is given this 0.5 plus relay resistance 0.5 and plus stabilizer resistor it is 300. So we found the voltage drop through the fault. So will be equal how much? It is equal around 2119.24. Okay, now let's calculate the MOV. So the MOV metro cell resistor will be equal how? What's the equation? 2 the root 2 multiply VK, the knee point. I will open will be V fault minus the VK. Okay, this is the equation. Okay, so 2 multiply VK. How much the VK is given? 350. Okay, true fault. This is the fault. 2219.2 minus 350. Okay, so let's find the answer. How much the answer? Okay. So the answer will be equal how much? 2287.74. So this value, stable value of MOV, in some standard or some company, they say if the value of big value or this big value, sorry, this big value or big voltage, what we find 2287.7 volt. So some company they say of the big voltage, okay, of the big greater than 3 kV, then the metro cell is important or is required. If the peak voltage is less than 3 kV, the metro cell no need to install. Okay, so the value we found here 2287, it is less than required is 30 kV, 3 kV. So the metro cell it's not important or not considered in this case. Okay, but some company also they say from 2.5, but mostly they use if the big voltage greater than 3 kV, the metro cell is required, and if the less, the metro cell is not required. So in this case, we have this value, big voltage 2287, it is less than 3 kV, so the metro cell it is not required in this case. Okay, thank you for watching, and I hope this will be benefit to you. Okay, thank you so much.